looks pretty good. One thing I do like to beware of is with board-mounted pots, the pads are bigger and the drill hole is also larger. So you don't want a component right up on that pad that doesn't connect to it. Like this is okay because it's going here. This is a little less okay because this is not connected and this is going to be a big pad. However, this is the ground plane, so there's going to be plenty of fill, so I don't really need to worry about that one. But had there been had this not been going to ground, I would probably move this up just enough so that the pad that's going to be created down here in the PCB etch part doesn't conflict with the larger pad right next to it. So from here we can we'll make that angled. That'll be fine. From here we can now create the etch image, and how we'll do that is we'll take our components, lock them, and we'll go ahead and grab the ground and the board, copy those, and paste them down here. Deselect the board and group that. Let's make it black, and then we'll make it really thin. Now if you've gotten to this point and you're like, how does he do a ground plane in DIYLC? I don't. I do that in Photoshop. There's not really a way to do it in DIYLC. There is this big fill, but that's really only for filling inside traces, and it would be a real pain to not do it in Photoshop. Now we'll scroll back up and select the rest of the trace, deselect the ground and the board. We don't need that. Copy and paste. Yeah, that matches up. Now before you deselect that, go through and just deselect the pads, because as we saw earlier, we can't group pads and traces together and change the color. It just comes up as a layer thing, and we can't do anything with that. Looks to be all of them. Now we group the traces that are left, and then we can go in, double click, and change those back to black. Leave them grouped, because now we're going to select the whole bit, then deselect the ground, the board, and the traces. Now we can group the pads and turn them back to black. Now, as I alluded to earlier, the pads for the pots are larger than normal pads. So I'm going to ungroup that and deselect these pads, which are the off-board wiring pads, which I used to make bigger, but it's not really necessary. But it is necessary for the pot pads. So those are all grouped together. Now we're going to make the hole for that 1.2 millimeters and the size 0.1 inches. Yeah, I know we're mixing measurement systems, but that's just kind of how it's set up, and it's what I've been dealing with for the past 3 or however long I've been doing this. 3 years? 4 years? I don't know. It's been a while. Now, generally a marker on a circuit board that shows just to indicate which pad is pin 1 for the pot is a square pad instead of the circular. So we're going to ungroup all that and select pin 1 of each set, or of each set of pot pads. Bah, that's kind of a mouthful. Make those square. Cool. Now this one, as we noted up here, there's a component really close to it, but because it is the ground pad, and there's going to be a lot of fill around it, that's not a big deal. So what we can do is we ungroup those square pads, and we'll just make this the normal size, but leaving the whole 1.2. And that way when the pad for that 3.3N cap comes in, it won't interfere. Now for these pads, the offboard pads, I make them squares as well, just to kind of differentiate them from the other component pads. Ground, it doesn't matter because it's going to be a big whole plane. And I will go ahead and ungroup that. Actually, at this point, we can just go ahead and ungroup the whole thing. Great, now we can come up and unlock the components. And what we want to do now is actually lock the trace. That way we can just select the components, deselect the board, copy, and we'll unlock the trace again. And we want to make sure now, before we paste those components down here, that 0.09 is the default pad size. Then we turn back on auto create pads, and then we paste the components down here. Then we group all those components so that it's easier to delete them later, and we go in and we'll lock the components. So now what we want to do is make this larger. Now we want to take a couple of these pads and make them squares. Again, similarly to why pad 1 of a potentiometer is a square, it indicates something. In the case of electrolytic capacitors, that's the positive side. So we go through and select all of those. I think that's all of them. Nope, this one. And then the indicator side of a diode, that's also square. And pin 1 of these trimmers, which is this one, select, come on. This one, that one, and this one. Those should all be squares too. And then I mark the gates of each JFET as a square as well. That would be this pin, this pin, this pin, and this pin. And we make them square. And ungroup. Now a couple other things that I do is add pads for if you're using a different size component. Generally that's with capacitors and the trimmers. If you're using smaller ceramic caps or just smaller like Panasonic film caps that are lower voltage rating than the Mylar, the big greenies, we'll add a pad there so you don't have to stretch components too far. And then with the trimmers, we'll copy that square pad. We want to add these pads so that you can use trimmers that are either inline, kind of like we'll come up here. An inline trimmer like vertical inline, like that, or a vertical offset, like that, where the pins are offset like that. And then there's also the larger big flat ones that also have offset ones. The pins are up here instead of back here. So that's why I add those, and that's what I'm doing now. Then just make sure to connect the appropriate traces to those new pads. So we'll throw that pad there in the middle of that one. That's good. And then we'll do the same. In fact, we'll just copy and paste this up here. If we don't need that trace there, we'll just continue this one. And add that. Add another one here and another trace. Great. Now at this point, we can go ahead and unlock the components and go ahead and delete those, because they were just there to create all the pads for us, or most of them anyway. This is where you can use that ground fill that's in the program. It allows you to fill in some spaces from adding these extra pads, and just traces of the same line that are close together. We forgot one down here. Connect that up and fill it in. Another thing you can do is add a little more mass to the voltage rail. It's not all that necessary, but it helps kind of even the voids out, so you don't have too much well, on here white space, but blank space when you etch it. Less white space means less time to etch and less etchant actually used. And if you're using ferrochloric acid, the less time you have to be around that stuff is probably the better. So I'm just cleaning up, adding little angles, because I like the way they look. Again, I'm a designer, and it's OCD stuff like this. You don't have to do this. Make them, make your layout style your own. This is just my style, So add them in the corners here. This is kind of a holdover from before I made a ground plane in Photoshop. You'll see in some of the early layouts on the blog, it's a whole bunch of, there's not necessarily like a straight trace like this. It's a whole bunch of blobs to fill voids before I figured out, hey, I can do that in Photoshop, and save myself some effort. And copy and paste those and rotate them. Now where there's a square pad, I'm not going to put a diagonal here, just so that there's enough room, and you won't make a short there when you're etching it. Let's fix that. Good. We got one here we can adjust, rotate, and up here too. So we have mostly completed this, looks like. Yeah, I don't see any more little angles to add. Oh, we do need to connect this pad for this trimmer. There we go. Now that will actually work. So from here, we need to make the labeling on the PCB and the perf a little easier to read. Since we have the in pad and the out pad right below these pot connections, this isn't going to work right here, because we need to indicate that that's the output. So I go over here to shapes, select a square, and put it over a group of pads for the pot. Reduce the alpha down. That's the transparency of it. Make the border white and give it about a 2 millimeter radius just to curve things around. That way you can still see the pads for the pots, and I can put the label over top of it and everything's still mostly pretty readable. Copy and paste. Now if I have pot connections that aren't like over here, if my in, out, ground, and 9-volt were all right here, I would probably just leave the labels here and let people, you know, oh, up there, that's where the pot is connected. But since we've got these connections right below it, it doesn't make it as intuitive. So we're just going to go ahead and add these transparent white squares to make it a little clearer. And we'll do the same over here. Great. Now we can, I think that's the only text that's on the text layers that have been on. So we'll go to layers, text, select all. I should select those. Yep. Copy and paste them. Great. Now I can go back over to miscellaneous to the text again and say this is the input. We'll align it to the right and rotate it 270 degrees. Label this as the 9-volt, positive 9-volt. And this is the ground pad and the output. Now we can just copy these there. And while I'm doing text, we'll just copy this, put it over here. This is the underside, and that it is reversed. And I will flip this in Photoshop. Now we need to give a little more information on the components that aren't seen, namely the pots. We have the gain or volume pot being 1 meg an audio taper. So we'll say volume A for audio, 1 meg. Oh, let's realign that to left to the default orientation. And we'll say base is, what was base? A250K. Make this one centered. The mids control is a linear, which is a B, 10K. And then we'll make the treble, which I think was also an A250K. Yes. And then the master is an A100K. Which is pretty standard for volume control. Great. And under here, we'll say that Q1 through 4, so J201. I think that's all the information we need. in the description, I will say that, adjust drain trim pots for 4.5 volts. Great. So it looks pretty good. Gonna make the project size 5 7/10 high. Yeah. And zoom out. Got room on the sides. Let's make this 5.3 wide. Cool. And that leaves us room up here for our label. Oh, forgot one little thing. Layout by storyboardist. That's me. All right. Stick that in the middle. Give it about 120 font size, and chunk 5 is what I use for runoff groove, and call it the ROG Uno. One more thing, we have one more label to add, and that's showing the pins for Q3, which, since it's sideways, here I'll show you. When it's this way, you can put the pin out in the value, but if you rotate that thing, the text stays in the same orientation, but the transistor moves. So you have to go in and label it manually. So that's DSG, and we should make it white and rotate it. Great. So that's the DIYLC portion.